4.3 Notes and Practice, Ionic Names and Formulas, Level 2, Polyatomic Ions. If you haven't done assignment 3.4 yet, you should go back and do that one because that one is Level 1. Guiding question, can more than two elements bond in ionic compounds? Goal, I can write formulas for compounds with polyatomic ions. So far, we have learned to write formulas for binary compounds. Bi equals 2. Just as a bicycle has two wheels, binary compounds are made from two elements bonded together in a ratio that makes them both stable. Potassium oxide, or K2O, is a binary compound. I'm going to bring you to the end of this worksheet where I added something to mine from assignment 3.4. So binary compounds have an element from the left side of the table, which is the positive metal side, bonded to an element from the right side, which is the non-metal negative side. And we know naming them, we name the metal as it is on the table, and the non-metal, we have to change the ending to "ide." So this is from assignment 3.4, and if you want to take a screenshot of this to have it handy, you could. So always pause whenever you need to fill in your worksheet as we go along, or take screenshots. However, reading here now, many ionic compounds contain more than two elements. In these, either the cation or anion, or both, might be a polyatomic ion. Cations are positive, anions are negative. A polyatomic ion is a group or team. Fill that in. A team of atoms with a charge. Hydrogen sulfate, or H2SO4, contains a polyatomic ion. Let's draw a line between the H2 and the SO4 so we see it better. So we see capital H, that's hydrogen, but then we have two more capital letters. So that means it's two more elements bonded. That's our polyatomic team. So let's look at these binary compounds, which are two elements bonded. If we draw a line between, we can see they each just have two capital letters. And with the polyatomic over here, we see more than two capital letters. For this one, the Ca is the positive, that's calcium, but the NO3 is a polyatomic ion. On this one, the K is a single atom ion, but the capital C, capital O3 is called carbonate, and that's a team. And this one, the team comes first, it's positive. The NH4 is a team called ammonium, and the Cl is a single atom ion. So when looking at a compound's formula, how do we tell it contains a polyatomic ion? The easiest way is to notice that there are three, or at least three, capital letters. That means there's a polyatomic ion. So you can pause and type that into your worksheet. The polyatomic ion team always stays together. Like most teams, they have a team name. Look at the ion chart at the end of this worksheet. What is the name of these ions, polyatomic ions? So I'm going to look for CO3, OH, NO3. Okay, I'm going to look down here. Now here is our polyatomic ion chart, this pink and blue one. On the left side, we see that it says positive ions and common transition metals. So these here we're not going to use today. Those are just some transition metals, the metals that are in the middle of the table that we haven't really talked about much. They are in this part of the table. They don't really have a pattern to their charge, so we just have to look them up here. But for today, we're not worrying about those. We're looking at ammonium on the left side, and then on the right side here in the blue, we have the negative polyatomic ions, and there's a lot of them here. So we see the name, the special team name on the left, and that goes with this formula on the right. So instead of naming all of these things separately, we give them that team name, acetate. But now I'm looking for CO3. So if I look down the list, oh, there it is. CO3 is carbonate. And then I was looking for OH. There it is, hydroxide. And I think the last one on that list, I'm going to have to look. I don't remember. Oh, NO3. And so there's NO3. Those are three that are pretty common. Okay, so I'm going to type those in and you should do the same. The next question says, give the name, formula, and charge for the only positive polyatomic ion on the chart. So I'm going to look down here again. There was one positive one on the left side that I'm using pink for that side. Ammonium. Ammonium is NH4. I got that one ready to go. All right, pause if you need to. So when we're naming ionic compounds, did you notice above that both ions of ionic compounds have a two-word name? Both types of ionic compounds. So whether it's a polyatomic ion or a single atom type ion, a binary, like up here we see by the bicycle, potassium iodide, potassium oxide, two words. And then here in the yellow, hydrogen sulfate. They both have two words, whether they have a team or not. So if it, in any case, the first word is the cation, always the positive first, and then the second word is the anion. The first word might be a single element metal, and if it is, you name it the same as on the PT, periodic table. Or if it's a polyatomic ion, you use the team name from the ion chart. On the blue side here, the second word is the anion. If it's a single element nonmetal, you change the ending to "ide." If it's a polyatomic ion, you use the team name from the ion chart. So for some naming practice, the list below contains a mix of binary compounds and polyatomic compounds. First, draw a line between the cation and anion. Look for capital letters. Then name the compound following the rules above. So here I see H2SO4. I know that the polyatomic must be the second part because remember the only positive one, and the positive one always comes first, the only positive one is going to be this NH4, okay? So I don't see NH4 at the beginning of this formula here. It's just H, and then SO4. So I'm going to look down at the charts, and I know H is hydrogen, and now I'm going to look for SO4 on the right side because it's the second one, it's the negative one. And I look down the list, SO4 way down here, that's sulfate. So it's going to be called hydrogen sulfate. Okay, the next one is MgO, and it's capital MG, capital O, so this is a binary one. So Mg we name just like on the table, magnesium. And your periodic table has the names if you need it. But there's magnesium on the periodic table. And then O is on the periodic table, but it's an anion, so we have to use the anion name for O, which is oxide. It's going to be magnesium oxide. We learned about that in assignment 3.4. Okay, this next one, capital BE, beryllium. I remember that from when we memorized them. And then PO4, I'm going to go look that one up. That's 2 capital letters, so that's a team. Here it is, PO4, phosphate. So the name of this one is beryllium phosphate. See, always 2-word names. This one, capital AL, capital I. Oops, I kind of got in the wrong place. AL is aluminum. We name it just like on the table. And now I is iodine, but remember we have to use the ide name. So here is iodine and it becomes iodide. Always they drop the ending and change it to IDE. All right, I'll let you try the rest of those until we get to the last one. I'm going to jump to that. See here how it's capital N, capital H, 4, Cl. It will be helpful if you start remembering that is our ammonium ion, like I highlighted in yellow here. NH4. So this is the one, the only positive polyatomic ion. So it's the only time when you see the team first. So that's called ammonium. And then Cl would be chlorine, but we change it to ide, chloride. Okay, let's keep going. So here's an example. I'm going to make a Post-it and cover that up so we can do it together. All right. So we're going to name this one that's called up here, example 1. I'm reading in the top box, ammonium nitrate. Hint, it's helpful to memorize that ammonium is the only positive polyatomic ion. And then for nitrate, the 8 ending helps you to know that it is a polyatomic ion, so we use the ion chart. So the first step is to write the symbol and the charge, just like in 3.4, only this time we have these polyatomics. So I'm going to go down and look for ammonium. And that one is NH4. Remember, it's the first word, so it's going to be on the left side of this table, NH4. And then the second word was nitrate, NO3. And I need to also know the charges. So NH4 plus 1, NO3 minus 1. I'm going to write those here. Now, like in assignment 3.4, we ask ourselves, do the 2 charges add up to 0? If so, it's a 1-to-1 ratio. And then we just write the symbols just like they are on the ion chart, and we're done. So do plus 1 and minus 1 add up to 0? Yes, when they're the same number but opposite, then they do. So I'm just going to rewrite them closer together, keeping those subscripts because that's part of the team. And that is the formula. And as we see below, maybe this picture helps us a little bit. NH4 is one team with an N and 4 H's. I see that here. With the plus 1. And NO3 is another team with the minus 1. So we need one of each team. And that's what is represented above by these symbols. Okay, let's try the next example. I'm going to add a sticky so I can do it with you watching. Okay, now this one says calcium hydroxide. Calcium is not a polyatomic. Remember, the first word will always be positive, and the only positive polyatomic ion is ammonium that we just saw. So for calcium, I'm going to use the periodic table, and then the next word here is hydroxide. And it's good to memorize that OH is hydroxide. Since it ends with "ide," it can be confusing. So calcium, I need to use the periodic table. Let's get rid of some of this. So I see calcium is, since it's positive, I'm looking in the +1, +2, +3 columns. And here it is, calcium, so it's +2. And then I'm going to look for hydroxide. Now, the "ide" ending might make you think it's one of these from the periodic table, but there's no element called hydroxygen or anything, hydroxium or something. So it's not, it's hydroxide is OH. Here it is. Okay, OH -1. So that was calcium +2, OH -1. Now, do they add up to 0? +2 and -1? No. Since they don't add up to 0, I'm going to add another one of the OH to make it cancel out or balance out again. We want them to be neutral. So now +2 and -1, that adds up to 0. So now I'm going to show in the formula that I need 1 Ca. So to do that, we just leave it with no subscript. But for the OH, I need to show that I need 2 OHs. So I'm going to write OH, but then I'm going to put a parenthesis around that team and put a 2 below. Notice the 2 is on the outside of the parenthesis, and that helps me to see that there are actually 2 of those. So here's my calcium, the positive one, and then the OH, I need 1 OH group, another OH group. And that's how that 2 helps me see that I need 2 of the whole team, not just 2 H's. On this box, on these boxes, you're going to write formulas, and I'm giving you the cation and the anion symbols. And so for this one, part of it's done for you already. On this side here, we have complete these formulas to show the correct ratio of ions. Use parentheses when necessary. So on this one, our cation is always going to be the ammonium ion, and then we're going to bond that to 3 different anions, chloride, oxide, and phosphide, to see the different ratios. So with the first one here, NH4 with Cl, it's a 1 + 1 - 1. So we just have a 1-to-1 ratio, and you see that here. NH4 is, there's 1 NH4 team and 1 Cl. No parentheses because there's just one of the team. With the next one, we see NH4. I'll make it pink again, with O this time. And that's a +1 - 2. So then I needed to do 2 NH4s to add up to 0 with the O2-. And so now I want you to add this. We had to use 2 NH4s, but we have 2 of the team. So I'm going to put a parenthesis around the team, NH4. Oops, went too far. Make sure the 4 is in there. But then I'm going to put a 2 outside of the parenthesis, 2 also. So NH4, 2 with the parenthesis. And then the O. Let's try it with the phosphate. So if I start with my NH4 plus 1 and my phosphate 3 minus, they don't add up to 0. So I'm going to add another NH4. Oops, that didn't mean that to happen. Another NH4. And do they add up to 0 yet? Nope. So I need another one. I have to have 3 plus 1s to balance the 1, 3 minus. Now I'm going to count. I have 1, 2, 3 NH4 teams. So I'm going to write in a parenthesis the team NH4. That doesn't change. But the little 3 outside tells me I need 3 of those. And then I need only 1 P. So I'm going to put capital P with no subscript and no parentheses. We don't use parentheses when it's a single atom ion. All right, on this side, same thing, only we're going to bond 3 different cations to the same anion. And the anion is carbonate, a polyatomic. So I'm going to put Li 1 plus CO3 2 minus. Do they add up to 0? No. I need another Li to balance that CO3. So now I'm going to count. Now they add up to 0, so I'm going to count. Start with the positive. 1, 2 Li's. So I'm going to write Li with a little 2. And then I have 1 of this team. Remember, it's a team, so all of the parts of it are important. So I keep the 3 because that's part of the team, but it's 1 of the team, 1 CO3. Okay, I think that I'll let you try the next ones. And down here, it's more of the same, but you have to look up the names and the charges. Look up the names to find the charges. So, for example, if we cover this one up, we'll do this one together. I'm going to look for the name, aluminum sulfate. Aluminum sounds a little like ammonium, but it's not ammonium. That's aluminum, so that's on the periodic table. Ammonium was our only polyatomic positive, but aluminum is just a single atom. So here's my periodic table. Let's get rid of some of this again. It's going to be either in the +1, +2, or +3. You might remember from before, it's +3. And then, so I'm going to write Al +3. And then sulfate. The ATE ending hints to me that it's a polyatomic ion. So that's not that's not just S, sulfur, because then it would say sulfide, right? Sulfur becomes sulfide. That is a polyatomic called sulfate. Get rid of some of this. So here is my SO4 sulfate. So I was looking for the word sulfate, and I see it SO4, 2 minus. I need all of that information. SO4, carefully copy it, low little subscript, charges go up, 2 minus, charges go up high. Lots of details here. Now we ask ourselves, do they add up to 0? And we have 3 plus and 2 minus, so nope, they don't. So this is where we have to start listing until they do. I see that I have more positive, so I'm going to add 1 to the negative side. Notice it's copied exactly the same as the one above. Now I have too much negative. 2 minus makes 4 minus. So now I go back to the positive side, and I'm going to copy exactly what I have above. Now that one adds up to 6, 3 plus and 3 plus. So now I have too much positive again. I'm going to go back to the negative side. Now I have -2, 4, 6. So when you ever have 3 against 2, you're going to end up with a list that looks a little like this. 2 on one side, 3 on the other. That's about as long as the lists get. So you can do it. Now we see how many do we have. We count. I have 1 AL, 2 AL. So I'm going to write AL2, little 2 down low, subscript. Now, how many SO4s do I have? 1, 2, 3. So I'm going to write the whole thing. Since there's 3, I need a parenthesis. I'm going to put the name of the formula for the team in the parenthesis, SO4. But now there's 1, 2, 3 of them. So I'm going to put the 3 on the outside. And that's how you do it. Good luck, and email or come in for help if you need it. And also the other videos posted are helpful too. Thanks for watching. Bye.